Hey guys, I'm gone to a match as you probably know, but I do feel it's important that we correct the homework and keep going with the area and volume, okay? So this was the first question you had to finish, and okay, I didn't write out all the question, but you can have a look at it. Basically, there's a garden here, and some of it is watered with hoses or sprinklers, and the blue bits are the bits that are watered, and the green bits are the bit that the water doesn't hit. And if we look at the whole garden, it's 12 meters by 8 meters. Okay, so what they're looking at first, or what they're asking us for, is what is the radius of the circle? Well, so here's one of the circles. Well, I suppose if you look at it first, it doesn't tell us. Okay, and just remember the radius is from the center of the circle out to the edge, right? But what they do tell us is that from here to here is 12 meters. Okay, and if you look at the circles, 3 of the circles exactly fit into that 12 meters. So we should divide our 12 meters by 3 and we get the diameter of a circle. Yeah, so if we divide that by 3, we're going to get this distance. So 12 divided by 3 equals 4. So the diameter equals 4. Therefore, 4 meters. Yeah. Therefore, the radius will equal, well, the radius is half the diameter, so 2 meters. That's our first question done. Second question. What is the total blue area? Okay, well, let's have a look at this. The total blue area is this circle, and this circle, and this circle. And, well, there's 2 half circles, so that's 1. And there's another 2 half circles, so that's another 1. So that's 1, 2, 3, 4, 5, and then 4 quarters. So there's 6 circles. Okay. So there's 6 circles there. Right, very important. So what's the total blue area? Well, the total blue area is the area of these 6 circles added together. Okay, could I get the area of one of the circles? Have I enough information? Well, the area of a circle formula is, so area of a circle equals pi r squared. Okay. So, well, we know what pi is. We'll go 3.14, okay, or 22 over 7, or just leave it as pi. Multiply by the radius, which is 2 squared. That equals 3.14 multiplied by 4. 3.14 multiplied by 4. I actually don't have a calculator on me, so let's do it quickly down here. Is 12.55 meters squared. And that's the area of one circle. Okay, I need the area of 6 circles, so it's 12.55 multiplied by 6, which is, do it down here, which is 75.3 meters squared. Okay, so there is the area of the total blue area. And the last bit then, question 3, find the nearest whole number, the percentage of the lawn that is watered. Well, first of all we put it as a fraction, so it's 75.3 all over. So it's the part of the garden that's watered over the total area of the garden. So 12 multiplied by 8 is 96. Okay, so again it's the total of the garden, so it's the bigger one on the bottom, smaller one on the top, and we multiply that by 100. Okay, and you should get to the nearest whole number, which is 79%. Okay, so hope you got that one right. If not, take a look at it, take it down, and pause this if you want, okay, and take it down from there. But I would be hoping you'd have got at least 1 and 2 right. Okay. Okay, guys. So next question. We have a windscreen of a car, and there's the wiper. And the windscreen is 160 centimeters long and 80 centimeters high. And there's just one big wiper on it, and the length of the wiper blade is 75 centimeters. And I'll just write this in. You can't see it. I suppose the angle that the wiper blade moves is 165 degrees. Okay, so that's 165 degrees. You have it in your book anyway. So what are they asking us for? Well, they're asking us for the percentage of the windscreen that is not cleaned by the wiper. So they want to know percentage of the white compared to the overall windscreen. Okay, so they're only asking us one question. So usually they'll give us a question and then another question that will lead on to the last question. But this one, they're just basically giving us the last question. So before we get to find this, we need to do a lot of work. So in order to be able to find the percentage of the windscreen not cleaned, first of all I need to know the area of the whole windscreen. Okay, and that'll go on the bottom, and on the top then will be the area of the not cleaned windscreen. Okay, and that'll go on the top, and I will then change my answer into percentage by multiplying it by 100. So I need to find these two things first. So the first thing, I will find the area of all the windscreen. Okay, so I'll do this, the area of all the windscreen. That'll be the easiest bit. And if you're in an exam and you are really stuck, well, that's one thing you could do. Okay, so the area, all the windscreen, well, it's a rectangle, so it's length multiplied by breadth, or length by width, or width by height, and that is 160 centimeters multiplied by 80 centimeters. Okay, and that'll give you 12800 centimeters squared. Okay, so I'm going to write that over here. This is 12800. So I have the area of the whole windscreen. Now I'm going to try to find the area of the not cleaned windscreen. Well, it's a funny shape, this white stuff, isn't it? I mean, I don't have a formula to get the area of that unclean bit. However, this is more like a shape. The area of the clean bit, well, that's resemblant of a circle, isn't it? It's a sector of a circle. Okay, well, the area of a whole circle would be pi r squared, correct? But remember, this is a sector of a circle, so I want to find 165 degrees out of the 360 degrees of a full circle. I only want to find 165 degrees of that full circle. Okay, so how we do it, and we've learned it already, is we put the 165 over the 360. Okay, and now we'll just slot in what we know. So pi, which is 3.14, multiplied by the radius squared, which is 75 squared, multiplied by 165 all over 360. Okay, and that will give us, just one sec, I'm just going to round it to the nearest whole number. So that's that. Now be careful, that's the cleaned bit. Okay, but we're not asking for the cleaned bit, we want the not cleaned bit. So if this is the area of the whole windscreen, okay, and this is the area of the clean bit, well, if I take that from that, I should get the area of the unclean bit. Okay, so that is 12800, take away 8095, which will give us 4705 centimeters squared. Okay, so that's the area of the unclean bit. Okay, so it's 4705, and if I multiply that by 100, I will change it into a percentage. Type that into my calculator. Remember, to the nearest whole number, it's 37 degrees. Okay. If you look in the back of the book, they're going to say 63. Okay, it's wrong. What they have done is they have found the area of the cleaned bit, but we weren't asked that. We were asked the area of the not clean bit. Okay, so they've done that wrong. Okay, so we'll go on to the next one in a sec. Okay guys, so we're on to volume. Okay, we're done with area, you'll be glad to know, and we're on to volume, and this is your homework for tonight. Please do page 102, question 6. Alright, it's not that long. And when finished this video, could you do question 1 and 4 on page 102? Alright, this is going to be going into your notes. Right, so if we can have a big heading on your notes now, so if you want to pause this video and get your notes ready, so neatly, can we have a subheading, and it's called volume, right? And I want you to take this down. Okay, so just that and then that, right? You don't have to take this down, so you can pause this and take it down. Okay, all right. So we're going on to volume, and volume, area is dealing with flat surfaces or flat objects. Okay, so circles, squares, they're all flat. But volume is dealing with 3D objects. Okay, so cubes or rectangular solids. Okay, and later on we'll go on to spheres and cones and cylinders. So they're all 3D. What volume is the amount of stuff that will fit in a 3D object. Now, in the area, we gave our answers in centimeters squares. Okay, so there's a centimeter squared, okay, or a millimeter squared, which would be something very small like that, or a meter squared, which would be something very big. Okay, but it was flat. Again, a centimeter is just a length. A centimeter squared is a flat, I suppose, square with sides of 1 centimeter. But now we're going on to these 3D images, these this depth. So we're going to be given our answers in either millimeters cubed, centimeters cubed, meters cubed, or kilometers cubed. And roughly that's a centimeter cubed. It's a centimeter of length, of height, and of breadth or width. Okay. So it's like a dice. And really what we're going to be looking at is, we're going to be looking at objects like this and objects like this, and we're going to be asking ourselves how many of these centimeters cubes can fit into this, okay? Or how many of these millimeters cubed, which would be something very small like that, would fit into something. Or if we're looking at really big things like houses and things like that, and the volume of a house, how many meters cubed would fit into the house. Okay, generally though it'll be centimeters cubed. Okay, so here's the formula. Volume of a rectangular solid is length, this, multiplied by breadth, which is how deep it goes back, multiplied by height. Okay, but I like to kind of think of it another way. I like to just progress it on from the area. So what I like to do in all these shapes is I like to find the area of the face of the object. Okay, so the face of the object is the front piece. Okay, so there's the face of that object. So I like to find the area that front piece covers. And when I do that, I'll multiply my answer by the depth. Okay, so how I'd find the area of this, I'd first of all find how would I find the volume of this? I'd first of all find the area of the face. Well, the face is 10 centimeters in length and 1 centimeter in height. So 10 multiplied by 1 equals 10. So that there is 10 centimeters squared in area. And to find the volume then of this shape, I multiply my answer by the depth, and the depth is 2. So it'll be 10 by 2, which is 20 centimeters cubed. Okay. Now the reason I do it this way is because when we come to more difficult ones like that, I still follow the same thinking. I just want to get the area of the front face, and then I'll multiply it by its depth. Okay. So if we look at something like this, okay. Well, I'm going to have to divide. Actually, I'll just draw this face first. The face looks something like that, and it's 3 centimeters up here. It's 14 centimeters altogether. 6 centimeters here, and it is 4 centimeters here, and 2 centimeters high. Okay. So if I want to get the area of this face, well, again, this is a kind of a strange shape, so we're going to have to divide it into shapes that we know, which are rectangles. So I divided there and there. We could also divide it across like that. Okay, it might have been handier to do it that way. So there's a few different ways. So actually, do you know what? We'll divide it across like this. It'll save us a bit of work. So let's get the area of this first. Well, it's 6 by 3. Yeah, so 6 multiplied by 3 equals 18 centimeters squared. And now we're looking for the area of this bit. And again, its length is 14 multiplied by the height is 2, which is 28 centimeters squared. And again, if we add the two of them together, we'll get the area of all of the face, which is 46 centimeters squared. Okay, the 46 centimeters squared is just the area of the face, so it's the area of this. But I want to find the volume of the whole thing. So once I have the area of the face, all I do is multiply by the depth. So it's 46 multiplied by 8. Again, I don't have a calculator, so 46 multiplied by 8 is is 368 centimeters cubed. Okay. I hope that makes sense, guys. You can start now on the work, and then if you're finished, you can get on to the homework. Okay, and I'll see you tomorrow. Okay, good luck, lads.